Hey guys, what's up? Here we are with part 1 of 2.8. This year we're just focusing on the linear part of inequalities first, and we'll pick up the absolute value part of inequalities at a later time. Okay, so how would we graph a linear inequality, such as y is greater than 2x plus 1? All right, we're going to start off graphing it just like y equals 2x plus 1. It's going to have a y-intercept of 1. It's going to have a slope of 2. The greater than, the inequality part, this part tells me it's going to be a dotted line, first of all, because it's greater than or less than would be a dotted line. And if it's just like an open circle, dotted lines are just like an open circle. Like those would be on number lines, but this is for like two-dimensional graphing. And it also tells me that we're going to shade on top of it, shade above or up. And we'll talk about some strategies for being able to recognize which way to shade. Okay? So let's get to it. So 2x plus 1, we're going to start at 1, y-intercept, and up 2 over 1, up 2 over 1, up 2 over 1, maybe go backwards a few, down 2, backwards 1, down 2, backwards 1. Okay, now this is the only spot that's really different. Alright, we're going to do, let me try to find a straight edge here, a dotted line or dashed line to show that it's a inequality less than. It's still a pretty poor line, sorry. Okay. And I said we're going to shade above it, okay? So think about this. All of these points on the line would make this equal, right? It makes it equal. That's where those points are coming from. Equal does not satisfy my inequality of y needs to be greater than. This shows me where y is equal, not greater than. That's why it's dotted. If this was greater than or equal to, then this would be a solid line because all of these points and all the points on the line would be included in satisfying the inequality. Okay? So, I'm going to shade on top. Greater than tells me to shade up in this situation. All of these points, it's not just one answer, it's every single point above the line, anywhere above the line, would make this work. Okay? Let's just take one of these over here. 1, 1, 2, 3, 4, 5. 1, 5. So 1 goes in for x, 5 goes in for y. 2 times 1 is 1. Nope. 2 times 1 is 2. Plus 1, I was already looking at that 1. Plus 1 makes this 3. We said 5 goes in here. Is 5 bigger than 3? Yes. So that worked, so I know I'm shading on the right side, the correct side. A common test point to use, if you can't tell which side is above the line, then pick a point and test it out in the inequality. 0, 0 is a super awesome one to use if you can, because it's really easy, right? It's really easy math. Okay? 0, 0 is not on my line, it's on one side. It's barely on this bottom side, but it's on the side, so it's okay to use to test it. Okay, so I put 0, 0 in here. 2 times 0 is 0, plus 1 is 1. 0 in for y as well. Is 0 bigger than 0 plus 1? No, that's not true, so don't shade this side, shade the other side. Okay, so we said greater than or less than dotted line because the points on the line don't satisfy the inequality. Alright, it's just like something like this. X is greater than 7. Alright, we would have our number line, we'd have 7, open circle, and then to the right. Okay, this is kind of showing us where I start, but 7 doesn't actually satisfy the inequality. It doesn't make it bigger than 7, okay? It shows me where to start, and I'm going to go from there. All right, let's have you try the bottom left one. Okay, and I'll zoom in there and give you 30 seconds, or I'll have you push pause, I guess. If it's a less than or equal to or greater than or equal to, now the points on the line are the or equal to part. They make it equal to, so that is going to satisfy the inequality, so there's going to be a solid line. So less than or equal to, greater than or equal to, we're going to graph with a solid line, and then we still have to think about where to shade. Okay, so I'll zoom in on that for you. And then you go ahead and push pause. When you're ready, go ahead. Oh, a little bit better. Okay, you can go ahead and push pause and figure that one out there on your own. Okay, welcome back. Let's see how you did. Okay, less than or equal to negative 3x plus 7. So plus 7, 1, 2, 3, 4, 5, 6, 7. I'm starting at 7 on the y-axis there. That's my y-intercept. Negative 3x for my slope, so that's down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. 1, 2, 3 over 1. Let's reverse the pattern. Doot. Backwards 1, up 1, 2, 3. Okay, solid line. You would use a straight edge. Okay, less than. To me, if it's set up like this, guys, in slope-intercept form, and the y is on the left-hand side like this, less than is going to mean lower. We're going to go underneath. Okay, if you're not confident in that, all right, look at what point 0, 0. It's over here. It's clearly not on the line, so this is going to be very helpful. 0, 0. Is 0 less than or equal to 0 plus 7? Is 0 less than or equal to 7? Yes. 0, 0 worked. Shade the side that has that on it. All right, so that's where we're shading. Okay, we just did spend some time on standard form, so let's practice graphing inequalities with standard form. Okay, so still the same thing. So you would cover up the x. 3y, 12 divided by 3 is going to be 4. So 4 on the y-axis. 1, 2, 3, 4. All right, now cover up my y. 2x and 12, so divide by 2. X is 6. 1, 2, 3, 4, 5, 6. Just like we talked about before. Okay, now the inequality part. It's greater than or equal to, so that's going to be a solid line. Again, you would use a nice straight edge there. Okay, solid line. Now the tricky part, it's not as easy to tell which way we need to shade, up or down. Okay, so now we definitely want to test a point. So let's test out 0, 0. Again, 0, 0, not on my line, so it's a good test point. If it was on my line, I couldn't use it because it doesn't tell me what side it's on the line, so it's not going to give away what side of the line to shade because it's not on a side. It would have been on the line. Okay, so let's test a point. 0, 0. If I put 0 in there and 0 in there, 0, 0, 0 for x, 0 for y, this becomes 0. This becomes 0. Is 0 plus 0 bigger than 12? Greater than or equal to 12? No. So don't shade that side. Shade the other side. Okay, I'm not going to get bent out of shape about how well you color in. You don't have to, make it clear that this is the side you're shading. Okay, that's what I'm looking for. You don't have to fill in every block or anything. All right. Let me see here. I don't have a whole lot more for you. Let's talk about maybe a story problem. It's a pretty amateur video, isn't it? Not having it all prepared for you. So this is just bonus coverage here for you folks. Applying a story problem. This one's right off the homework. We have somebody making necklaces and bracelets to sell at a craft show. And there are enough beads to make 50 total pieces. So we have enough beads to make 50 total necklaces and bracelets. Okay, X equals bracelets. Y equals necklaces. Write an inequality that shows the possible number of necklaces and bracelets that this person could make. Okay, so an inequality. X, number of bracelets plus necklaces, is less than or equal to 50, right? This person had enough materials to make 50 total pieces here, so necklaces plus bracelets needs to be less than or equal to 50. All right, that's going to be the book answer. All right, what the book isn't going to mention here this time, they might bring this back later, is that we sometimes need to take into consideration the common sense or real world restrictions. X plus Y less than or equal to 50. Okay, so I could think of like, can I make negative 25 bracelets and positive 75 necklaces? Because that would equal 50. No, okay. So when we're dealing with real world stuff, I call it the quadrant 1 restrictions. Okay, we need to stay over here. So I need my X's. All right, I can't make negative bracelets. Okay, so bracelets has to be greater than or equal to 0. And necklaces also needs to be greater than or equal to 0, right? We're staying here in quadrant 1. We're not slipping down here and making negative of anything. Okay, then it's going to want you to graph it. Well, this is already standard form, right? So we're going to have 50, 50. That's 0, 50. This one's 50, 0. Solid line, and we're in here. We're staying in quadrant 1. All right, we're not going into the negative quadrants, okay? And then it says pick 3 possible solutions, all right? Well, we could be boring and say 0, 0, 0, 50, 50, 0. That's boring. Okay, make some nice ones up in here. Let's see, 3 plus 25. So you could have 3, 25. You could have 47, 3. That would work. All right, find 3 things that would work and write them down. Don't pick the boring ones, 0, 0, 0, 50, and 50, 0, okay? If it's a quiz or a test, I would have to take that. You're right. But, like, don't pick the boring ones that are right there on the corners. Pick something fun there that shows that you thought about it a little bit. Okay? So that's the video for today. We're just doing lines. We're saving the absolute value inequalities for a later time when we're focusing just primarily on absolute value stuff. So we'll come back to that part later. All right. Thanks, guys.